Hey guys, today you will see like how to create your own mouse look script, and I'll just show you like the final results. So I'll just use this project as a example to show you this mouse look script, how it works. So I'll execute my project, and so you'll see like, so it's working normally like any mouse look program. So it's doing what it's supposed to do. So it's working like that. Okay, so I made this Unity project. I made it more simpler than the one we were watching a few seconds ago, to make it simpler to understand. So for my mouse look process, I'm gonna need to have like two C# scripts. The first one will be a class that will have as a method that will have as a input my mouse pointer screen coordinate. It will be like a vector3, and the second parameter, input parameter, will be like the maximum angle rotation. So this angle will be like my maximum rotation. The camera won't be able to rotate more than that angle from this side and from this side. So let's say if I put like 60 degree as a maximum rotation angle, so my camera won't rotate more than 60 degree or 80 or 85, but not 90, since I'm using for my process the tangent math function, and there is no tangent for a value for a for an angle of 90 degree. So 89, it will work for 89, but won't work for 90. Anyhow, it's not like a big deal. And how it will work exactly, the second script now will call my method, and actually it won't be changing the camera directly, the direction of my camera directly. Actually, just to go back, my method will return a vector3 direction. Okay, and this vector3 direction I won't associate it directly to my camera, to the direction of my camera. I will be using an empty object that I will create temporarily, and I will change the direction of that empty object, and that empty object then will change the direction of my camera. So this is how it will work. So to make it more clear, I created this scene in my 3D Max software, okay, to show you what I'm going to do exactly. So let's consider this as our screen. Okay, I made it a square to make it simpler. Okay, and this is my mouse pointer. So when my mouse pointer move like in my screen, so it's moving using its screen coordinate. Okay, but using my goal is to determine this vector, this I mean its value, XYZ value. Okay, and using just the mouse screen coordinate, I won't be able to determine this vector. Okay, I need to convert those coordinates, the mouse pointer coordinate, from screen coordinate system to another system coordinate where the camera is the origin. And as soon as we know those XYZ value, it will be easy to determine this the XYZ value of my vector direction. Okay, for that I need to determine the X maximum value using this new coordinate system where the camera is the origin, and of course the same goes for the maximum value of Y. Since my screen is a square, so maximum X equal to maximum Y value. Okay, so let's do some scripting work, and then I'll create my first C# script. I'll call it like vector direct. Okay, so I'm gonna delete this, and I'm gonna delete this, and I'll start by creating my first method, the first one, and I think it will be the only one. So I'll call it like, so it will be like public vector3, since my final results will be this vector, the value of this vector, so it will return a vector 3. Okay, so vector 3 vect there, its name. The input parameter will be like a vector 3 mouse screen, and the second one, it's a float value, and it's my angle limit. And since and for this purpose I will be using the angle in a radian system, not in a degree. So keep this in mind. So 90 degree in radian will be like a 1.57, and 45 degrees they have like, so it's 0.78 or 77. Anyhow, so float max angle. Okay, and then curly brackets. I'll open my curly brackets and close them. Here I need to determine the maximum x value, this value, this one. So I'll call it like var max x equal, and how we can determine this value. So we need to determine the maximum x value, and to determine this value we need to start by giving the z value of my mouse pointer using this new system coordinate where the camera is the origin. We can choose an arbitrary value of 50. We can choose whatever value you want. It will work. Okay, so we can consider this z value as 50. Okay, so to determine then the maximum x value, we know that this one represents the maximum angle. Okay, that is going to be our second input parameter in my method. So this value will be equal to this z value multiplied by the tangent of this angle. Remember, you need to enter in the angle in radian, not degree. So I'll go back to my script. So var maximum x is equal to 50. It's a float value. It's the z. 50 is the arbitrary value that I gave to my mouse pointer z value. Okay, in the my new system coordinate where the camera is the origin. Okay, so it's 50 multiplied by the tangent so I'll use like math function tangent of my maximum angle, which I already know. Okay, and since maximum x y is equal to maximum x, because my I consider that my screen is a square to make it simpler, so less process for my CPU. So I'll do like this: var max y is equal to max x, semicolon. And then now we need to determine the my mouse pointer coordinate in my new system coordinate where the camera is the origin. And how I'm going to do this, we will be using the proportionality rule between the screen coordinate system and my new system coordinate. Okay, so I will consider this. Let me explain this. I hope it will be more clear. So this is the proportionality rule. Let's say if you have A that is associated to B, and we know that X is associated to Y, but we don't know the value of Y, but we know A, B, and X. So to determine Y value, we will use the proportionality rule. How it will work? It's like that. We multiply x by b, and then we divide the results by a, and it will give us y. So to translate this in my actual problem, let me hide this, and so we'll see here. We know already like the position of my mouse pointer in screen coordinate. We already know that. It's something that we know, and we know the screen width. Of course, we can know it, and but we don't know the x, the coordinate x of my mouse in my new screen coordinate where the camera is the origin. We don't know that, but we know we already know the maximum value x in my new system coordinate. Okay, so it will be easy to determine my x mouse, the x value of my mouse pointer in my new system coordinate, okay, by using the proportionality rule and using this function. And it will give me this. So var mouse x equal, so this is the value x of my mouse pointer in my new system coordinate, equal, so we'll be multiplying the x value of my mouse in screen coordinate multiplied by max x divided by screen width. Okay, so I'll be using this. So this will have the mouse screen coordinate, this vector 3. So I'll use like mouse screen dot mouse screen x multiplied by max x, and we will divide everything by screen. Actually, hold on, I made a mistake, just one little mistake. It's not screen width, but screen width divided by 2. Okay, it's screen width divided by 2, but let's see why. So we are just calculating this one, the max x value. It's just this one, not all this. Max x value is this one. Okay, so it's like half the screen, not the entire, half the width of the screen, not the entire width. Okay, so this distance, this one, when we measure it like in a screen coordinate system, it will give us like screen width divided by 2. But when we measure the same distance in a coordinate system where the camera is the origin, it will give us like max x, our value. Okay, and the same works for the mouse position. Okay, and that's why we have this relation. It's the same relation between the mouse position in a screen coordinate system and the coordinate system where the camera is the origin, and the screen width divided by 2 and max x. It's the same relation. That's why we can use the proportionality rule to solve our problem, like the mouse, the coordinate x and y of the mouse pointer position. Okay, I hope it's clear now. Okay, so it's divided by 2. So screen width divided by 2 is associated to max x. Okay, so let's go back here. So screen dot the dot operator, remember, access and width. Okay, divided by 2 f, it's float value between parentheses. Okay, so this is my the x value of my mouse pointer position in my new system coordinate. Okay, semicolon. And let's copy this and paste it here and change this to y, and this one will be y, and this one y, and this one height. Okay, let's go back to this graphic. I'm gonna just hide this, and so this is and the same mistake is present here. It's divided by 2. We're just working with half the screen, not the entire screen. Okay, so I think we made it, since we know x and y, and we already know z, which is this arbitrary value. And you can see that those two values are dependent from this value. So any value we'll choose will work, but we'll have like different value here, but still it will work. Okay, it will work perfectly. So now I'll create my last variable, which will be my vector direction. So I'll call it like just temp vector is equal to my new vector 3 open parenthesis. So I'll use mouse x comma mouse y comma and my z value, which is 50 f semicolon, and then return temp vect. That's it. We are done with this class, with this script, the first one. Okay, so let's work on our second script, the script that will call this method. I'll go back to my Unity project, and then in here, in this folder, I'll just create a new C# script. I'll call it like a camera direction. I'll be doing some declaration statement. The first one will be like a Boolean value, so I'll call just private Boolean. I'll call just ready. A second declaration statement, private vector 3 mouse coordinate. Another one, private. It's a game object. It's private and game object. Okay, because I need to create like an empty object, and then I will use its direction to change the direction of the camera. You see how. I'll call it like empt obj. Okay, semicolon. That's it. In the start, I'll start by creating my empty object. So I'll use that empt equal new game object. I'll give it like a name, like empty object, close parenthesis, and semicolon. That's it. I'll be just creating an empty object just one times, and in here equal new vector 3 open input mouse position dot x. We need, let's go back to my 3D scene. even in screen coordinate, we need to make so the center, my center is not here, like with input mouse coordinate, input mouse position, but in the middle here. So to make this possible, I need to do it like that. Minus half the screen width. So all this, the screen width divided by 2. F, it's a float value. Comma. And I will copy this and paste it here. So I replace this by y, and this is by with 8. Okay. And comma, and we don't care about this value. I can just put it like 0. I don't need it anyway. And semicolon. Okay. And I will use like the a coroutine to call this function, my function, vector direction. I'll start by creating my coroutine. Writer. And the name of my coroutine, I'll call it like call vect direction. Anyhow, you name it whatever you want. Okay. Yield return. I'll just put null for now, but I'm sure I'm gonna change it later. Okay, so here I'll put like ready equal. So why I'm doing, you'll see like why I'm using this ready, this boolean value. Okay, just follow me here. Ah yes, I forgot something. Private my class vector direct lowercase v. I will just rewrite this vector direct. Okay, and okay, so now I'm gonna use empt, since I will work on my empty object and then use the direction of my empty object to rotate my camera, to change the direction of my camera. So empty object transform forward is equal to dot member access operator, and yes, this one, this method parenthesis. So I will give it like my mouse coordinate, comma, and my maximum angle. Since I'm using radian system, so I'll choose something close to 70 or 80. So it's like 1.2 f or 1.3 or whatever, something close to 80 degree. Okay, and then semicolon, and then I'll just, now I will change my camera direction. So I'll do like this. This script will be associated to my camera. That's why I won't be typing any game object name or something. So transform that yes, local Euler angles equal to my empt obj, my empty object, that transform Euler angle. Okay, and semicolon, and then I will just call my coroutine from the update. So if ready, I didn't finish it. Oops, sorry. And in here I'll just put ready equal to false. Okay. So if ready false, I will call my coroutine. Start coroutine parenthesis, the name of my coroutine, it's called like that, vect direct, okay, semicolon. So you understand why I'm using this boolean value. So what happened, like when ready is false, it will, like now, like because ready is false now, it will call the coroutine, and in here ready will be true, so it won't be able to call it again until it will reach ready equal to false. So it won't be called like twice in the same time or 3 times in the same time. So it will call the next time until it finish everything. That's why I'm using this. Maybe I'm sure there's a better way to do it, but this one, I know this one, and it's working. So there's no reason to don't use it. Okay. I forgot something very important. We need to instantiate our class. We need to have like an instance of that class. So we put like, okay, so it's equal to new vector direct open close parenthesis, okay, and I'll save my script, and then I'm going to associate this this script to my camera, okay. So just put it in here. That's it. And as I said before, this script will create an empty object, and it will change its direction, and then this empty object will change the direction of my camera. But when, I mean, look, those 2 lines, okay. So this line will change the direction of my empty object using my method from vector direct, and then I'll change my camera direction using the new direction of my empty object. That's it. So I'll press play. So as you can see, it's working. Okay. Thanks. As I said before, if you still have question, just contact me. Thanks a lot, and goodbye.